Hi, I am Sreedhar, Assistant Professor of Physics, Government Women's College, Tumkur. Today, again, I am doing the video, the quantum mechanics topic, in which the wave function and its properties. So, very important concept in this unit, quantum mechanics, wave function. So, wave function and its properties we are going to be discuss here. So wave function in quantum mechanics, it is postulated that there exists a function determined by the physical situation. So it means in quantum physics, so you know about the quantum physics. So there is a postulation or assumption made by the scientist. According to them, there exists a function. That function has to be determined by the physical situation. That means the function exists in any state of in quantum system. System, you know that about the system. System is the space which is surrounded by the coordinate systems. So that system in quantum state, so that is quantum system. In that quantum system, there are number of states. So there are number of states. That state is determined by the physical situation in the quantum system. So that is called the wave function. A wave function in quantum physics, it is a mathematical description. Mathematical description. So we are describing the state of the quantum state of that system, quantum state of that system, which is described by the wave function. So it is a mathematical description. It is a mathematical description of the quantum state of an isolated quantum system. Isolate means, so there is no exchange of heat or the mass, heat or energy. In thermodynamically, we can say that it is heat and energy. But in generally, we can say that there is no exchange of energy and the mass. Even in the quantum system, isolated quantum system, there is no exchange of the mass and the energy. In that such isolated system, quantum system, there are number of states. That state is described by the function that is called as wave function. So it is a mathematical description to explain the quantum state of that isolated quantum system. Okay, so from that mathematical description, we can evaluate or we can get the complete information about that state. So therefore, that quantum state described by the wave function, so this is a variable quantity. The wave function is the variable quantity that varies in space. So wherever we define the quantum state, that state is described by the wave function. That wave function is a variable quantity. That variable quantity varies in space and time. So that variable quantity varies in space and time. That means as the space changes, that means the position is changes, as the time is changes, that variable quantity or the wave function is changes. So that variable quantity that characterized by the de Broglie wave. So whatever the concept explained, the de Broglie, that satisfies the characteristics of the de Broglie wave is satisfied by that wave function. So therefore, it is called the wave function. That function is characterized by the de Broglie wave. So therefore, it is called as the wave function. So usually, we denoted that wave function by the letter psi. So in future, we use the letter psi regularly in this chapter. So therefore, you should know about this letter psi. Psi is a Greek letter the wave function is denoted by this Greek letter. The wave function mathematically describes the motion of the particle. So wherever the state is there, that state described in a quantum system, we can express that in mathematically. So that says that in that state the particle is under motion. The wave function mathematically describes in that state the particle is under motion. So which explains the motion of that particle. And I said it is a function of space. So whatever the wave function is there, it is a function of space and time, as the spatial variables are the x, y, z and the time variables. As x, y, z and time is changes, and the wave function is changes. Is purely depends on the space and time. It contains all the information about the state of the system. I said already. So the wave function, if you solve that wave function, you will get all the information about the state of the system. In that quantum state, there are number of states. That state is described by the wave function. If you solve that wave function, you will get all the information about the system. So suppose in that state, there may be a particle. So therefore, which is described mathematically by that wave function psi. If you solve that psi, you will get the position of that particle, you may get the momentum of that particle, you may get the energy of that particle. So therefore, in that psi contains all the information about the state of the system. Hence it is also called as state function. So state function, why? Because it is a state function. In a quantum system, there are number of quantum states. In that quantum state is described by that function. So that function is called wave function, because of which is describing the state, quantum state. So it is also called as quantum function. So what are the properties of that wave function? So one is the wave function must be single valued. So wave function should be, I said that wave function is depends on space and time. As the time changes, as the spatial variables x, y, z changes, the psi should also be changes. So that means to say that for the same value of x, you won't get different values of wave function. So psi value should be only a unique value for any values of x, y, z. So there are no other solutions for the same value of x or same value of y or same value of z or same value of time. So that means, so psi is a single valued for any spatial variables or the time variables. Psi and its first derivative must be continuous. Psi is the wave function and its first derivative means dou psi by dou x or dou psi by dou y or dou psi by dou z or dou psi by dou t. For any first derivative with respect to any variable, so both should be continuous. That means if you plot a graph, you will get a curve. That curve should not be break anywhere. It should be continuous for any values of the spatial values or with respect to the time values. That curve should be continuous. There is no breaks in that. So then the wave function must be finite for all possible values of x, y, z. So that means the psi should not be infinite. It should be a finite. For if you give any values of x, y and z, you have to get a finite value. You should not get any infinite values for any x, y, z and t. So therefore it is a finite for all possible values of x, y, z. And also the psi itself has no physical meaning, but psi squared evaluated at a particular place at a particular time is the probability of finding the particle at that time. So it means psi, the wave function psi has no physical meaning. There is no physical meaning, but if you get the square of the magnitude of the square of that value, so that will gives the probability of finding the particle in that state. So wherever the state is there in the quantum state in a quantum system, so that quantum state is described by psi. the psi squared value. So magnitude of psi squared value means it is the absolute value. So that value is the probability of finding the particle at that time. So wherever you find the wave function for that state, so it is the psi. So psi squared will give the probability of finding the particle at that time. So what are the physical interpretation of this wave function? So wave function psi by nature a sort of amplitude function. I said the wave function psi is amplitude function. So in classical mechanics we know that the square of the wave amplitude is proportional to the intensity. The intensity I is equal to a squared f squared. In that expression, the intensity is proportional to square of the amplitude. The same concept can be applied in this case. So therefore psi is an amplitude function. Therefore the square of that amplitude, square of that wave function is the square of psi squared value. Hence the square of the absolute value of psi. So that is psi squared. Psi squared is which gives the measure, which is the intensity or particle density. So psi is describes the state, quantum state of the quantum system. So therefore the psi squared will give the intensity or the particle density according to Max Born. So Max Born is the scientist. He gave the physical interpretation for a wave function. So according to him, the psi squared is treated as probability of finding the particle. Psi squared is the probability of finding the particle at any instant of time. So psi is, there is no physical meaning for that, but psi will be an amplitude function, just like an amplitude function. So that amplitude may changes. So but the square of that amplitude will, according to classical mechanics, it is proportional to intensity of the wave. So therefore psi squared is the intensity of the particle in that state. Intensity of that particle in that state, nothing but we can take this as the probability of finding the particle at an instant of time. Since the probability of finding the particle at a given point in a space must be real. So probability means it's a real number. It may be 0 or 1. So therefore 1 to 100 the probability. So therefore it is a real value. So therefore we have to take the magnitude of that psi squared. So but the psi, the function psi may be a complex. It may be a complex. So therefore we have to take psi star psi. So where psi star is the complex conjugate of the complex number, So therefore psi star psi is taken as the measure of probability of finding the particle at any time. So if a psi is a function, psi star is a complex conjugate, and their product will always be a real and positive quantity. So therefore generally, so the probability of finding the particle in certain volume. So if you take any volume, so the small volume, if you take the dx and dy and dz are the small volume, in that we are going to be find the probability. Then psi star psi dx dy dz is the probability of finding the particle in that space, or psi square dx dy dz will be the probability of finding the particle per unit volume. So then psi star psi will be the probability of finding the particle per unit volume, and it is also known as the probability density. So if we have the wave function of a particle as the value psi and at some point x, and the probability of the finding between the x and dx will be proportional to, so probability will proportional to psi squared into dx. This is for one dimensional. Suppose the particle is moving only along the x-axis. In some cases, in the 3D space, the particle may move along all the three directions. So then the volume element will be dx, dy, and dz. So then, so the probability of finding the particle between x and x plus dx, y plus dy, and z plus dz is the proportional to, the probability will be proportional to psi squared dx dy dz, or psi squared into d tau. The d tau is the volume element that will be equal to dx, dy, and dz. This is about the physical interpretation of wave function. Thank you.